Good morning. My name is Dominik Gnas, and I'm doctoral at Academia CEI and employ in Netrix development and research department. I would like to show you my presentation. The topic of my presentation is non-invasive impedance blood glucose meter. Let's start. What is diabetes? Diabetes is an illness. Everyone knows this. But in our world, we have 500 million people have this illness. So this is the global problem. Traditional method needs the blood, the finger prick several times a day. So this is the painful, this is the very, very uncomfortable. And so we must find the solution non-invasive to detect the glucose level in the blood. We want to create this device. We focus on impedance measurement method. And this is very promising alternative to classic device. What the bioelectrical impedance? This is the impedance for living organism, because impedance is for the capacitor, resistor, or coil. In the simply put, the impedance simply is the resistance for alternating current. The human body have characteristical impedance, so we want to find the characteristic for the glucose level. So how we start the measuring? We put the electrode for the arm, for the skin, and we apply the very, very small current to the human body. This current have 10 microamperes, so this is, we can feel this. And we put high frequency current. We change this frequency from 10 to 100 kilohertz. And we measure the impedance. Because in our device we have the current source, we know the current, so we're measuring the voltage. So when we have voltage and current, we can calculate the impedance. The next step was putting the data to computer software and analyze data. So the first, we must create the electrode. This is the input, our electrode. We measure this electrode measuring the voltage. This put to human body the current, and the middle we have the circuit, integrated circuit with IR LED and red LED, because we must to control the pulse and blood oxygen, because we want to have the same condition to our measuring, to our prototype. So this is the real electrode. This is the flex PCB, and the circuit was terrible to soldering, because the package this device was a QFN, so this have only up paths. So this is terrible. You can see here the block diagram our device. This is the second prototype. This is the second prototype. In first, we use STM32 and we communicating using USB. Now we change. We use the NRF52 because we want to transmit data wireless. So this microcontroller has Bluetooth. We have the block 8S spectral impedance measuring and power supply. This is the PCB. So we use the PCB antenna for Bluetooth. This is the heart, our device. This is the microcontroller. We add USB to debugging because this is optimization our process to programming our device. And this is the integrated circuit to measuring impedance. And this is the coil. Why I add the coil to measuring track? I talking about later, talking about the result. And here we have a connector to our electrodes. So this is our device. I told this is prototype. We have here wire. This clock is not good, bad footprint. So I must do something. And talking about measurement, I measure glucose using classic method. I prick my finger, and taking some blood to the classic glucometer. In the same time, I'm measuring impedance and measuring reflected light from the our circuit. So this is the result. Here we have the start my job. I'm not eating. I measure glucose level, and I eat sandwich. I do this sandwich, so I know what it is. So the glucose level go up, but slowly. I'm taking the measure on half hour. So I add only the change point. When the glucose level go down, I'm waiting, I'm measuring, and the next I'm eat the sweet, very, very, very sweet chocolate. So my glucose level go up, very, very up. This is the impedance results. So this is look the same, but this is not only. But we don't take only impedance. Okay, why I add a coil? Because if we take because human body have only capacitance. Okay, no inductive, only capacitance. So when we change the frequency of the current, we will have the straight line. If we take this the frequency, so low frequency, high impedance, high frequency, very, very low impedance. So we look the resonance between this coil, this impedance, and a human capacitance. And we look this resonance look on the frequency of the measuring. This is the reflecting light. We taking the data from this circuit. We can find some. This is the morning. I'm not eating. This is the value. We can find correlation between glucose level and reflected light. I trying to, because I'm when I do measuring. I'm measuring pulse and blood oxygen because I want to have the same condition. This is hard to have the same condition because I'm human and this can change. But I'm trying to search value of my pulse and blood oxygen. And thank you for your attention.